Hello, I am Peter, and I will be guiding you through this module on different mathematical tools regularly used in financial analysis. Covariance and correlation are extremely important as they measure the association or movement between two data distributions. In this video, I want to focus on the steps necessary to calculate these important measures. We will continue working step by step. Let's get started. We will perform the calculation step by step using Excel. The first step is to calculate the average return separately for each firm, TTI and GEC. This average return is the result of adding all the monthly returns divided by the number of months of data. We can also interpret it as the return we predict for each of these firms looking forward. After calculating them, these returns are 2.67% for TTI and 1.33% for GEC. Once you have the average return for both firms, TTI and GEC, you can now calculate the variance and the standard deviation of their returns. Remember that we performed these calculations step by step in one of the previous videos on standard deviation. Just to refresh your memory, we need to calculate the deviation of the return for each month from the average return. These deviations must then each be squared. Finally, remember that the average of these squared deviations is the variance and the square root of the variance is the standard deviation. You can verify that your answers are correct using the Excel commands var.p and stdev.p. The third step to calculate the covariance is to multiply, for each month, the deviation from the average of one firm by the deviation from the average of the other firm. For example, in cell H3, we multiply the deviation of TTI, which is minus 0.007, by the deviation of GEC, which is minus 0.003. In this step, we are multiplying the deviations without squaring them. That is, the values from column D with the values from column F. This will give us the interaction of the deviations of TTI and GEC. To elaborate a bit on the meaning of covariance, let's look at the returns for the month of March. Both returns are negative, and therefore both deviations are also negative. TTI has a return of minus 1%, and its deviation is negative 0.037, which indicates that the minus 1% is 0.037 below the mean, which is the same as 3.7% below the average return. GEC also has a return of minus 1%, and its deviation is negative 0.023, which indicates that the minus 1% is 0.023 below the mean, or in other words, 2.3% below the average return. When we multiply the deviation of TTI and the deviation of GEC, since both are negative, the result is a positive value. A positive covariance indicates that TTI and GEC move in the same direction. When the returns of TTI increase, the returns of GEC also increase, and when TTI decreases, GEC also decreases. Imagine that the return of GEC for the month of March was positive instead of negative, and that it was above the average return. In that case, its deviation would also be positive. By multiplying the positive deviation of GEC, in this hypothetical case, with the negative deviation of TTI, the result would be a negative value. This would mean that TTI and GEC moved in opposite directions. If you look carefully at column D and column F, you can notice that the deviations of TTI and GEC always have the same sign, with the exception of the month of May, where GEC had a return below the average, while the return of TTI was above the average. Therefore, in column H, the value of the interaction of the deviations is always positive, with the only exception being the month of May. Finally, we calculate the average of the interactions, which tells us what the usual behavior is between the movements of TTI and GEC. What do you think? Do they move in the same direction or in opposite directions? If the interactions in column H are predominantly positive, their average, which is the covariance, will also be positive. On the other hand, if these interactions are predominantly negative, the covariance will be negative. When we calculate the average of the interactions, we obtain a positive value of 0.00021. This tells us that, on average, TTI and GEC move in the same direction. However, covariance is a bit difficult to interpret, which is why we will standardize it, or in other words, convert it into a parameter that we can understand more easily. A correlation of -1 indicates that the two assets being evaluated are perfectly negatively correlated. When one increases by 1%, the other decreases by 1%, and vice versa. On the other hand, a correlation of +1 indicates that the two assets being evaluated are perfectly positively correlated. When one increases by 1%, the other also increases by 1%. A correlation of +0.5, for example, would indicate that when one asset increases by 1%, the other also increases, but only by 0.5%. A correlation of 0 indicates that the two assets being evaluated have no correlation, at least not in a linear manner. However, we must be cautious when interpreting this result, as they could have a nonlinear correlation. To better interpret the magnitude in which the comovement between TTI and GEC or any other pair of firms is positive or negative, we finally standardize the covariance by dividing it by the product of the standard deviations of both firms. First, we multiply the two standard deviations, 1.886% and 1.247%. The result we obtain is 0.000235, and this will be the divisor. We then divide the covariance, which is 0.00021, by the product of the standard deviations, which is 0.000235, and the result is 0.9. No matter which series of returns you evaluate, the correlation will always have a value between -1 and +1. One last reminder is that you can verify your calculations by using the covariance.p command and the correl command in Excel. These commands provide you with the covariance and the correlation coefficient, saving you from all the intermediate calculations. Thank you for your attention and for the great work you've been doing. Let's stay in touch.